Go for it.
Hi, I am Miss Rose. I've taught 1 algebra, geometry honors, 2 algebra honors, and trig. I've taught it all. I am going to be showing you how to do 1 algebra honors, unit 9, opener number 7. The goal is that you will be able to identify and use properties of exponents to solve problems. So the first goal is to determine the rule for multiplying expressions with the same base and the same or different exponents. So before I generalize and talk about the rule, it seems like we should do a couple of examples first. So example 1 is 3 to the second times 3 to the first. So I'm going to go ahead and use some properties of exponents that I already know and expand this. So 3 to the second is 3 times 3. 3 to the first is 3. And I know that 3 times 3 times 3 is the same as 3 to the third, or 27. So I have a hypothesis for what the rule might be, because I see that the bases are the same, and I see that it was 3 to the second times 3 to the first, and I ended up with 3 to the third. So I'm thinking that I might need to add the exponents, but I want to try a few more examples to make sure. So number 2 is 2 to the second times 2 to the fourth. So I'm going to do 2 to the second, which is 2 times 2, times 2 to the fourth, which is 2 times 2 times 2 times 2. And I see that I get 2 to the 1, 2, 3, 4, 5, 6. 2 to the sixth. 2 to the sixth is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So I'm going to look back at my example, 2 to the second times 2 to the fourth, and see that I got 2 to the sixth, and I see that my original hypothesis was correct. So if I go to do number 3, I'm thinking since it's 5 to the second times 5 to the fifth, it's probably going to be 5 to the seventh, but I'm going to expand it out just to make sure. So I did 5 to the second times 5 to the fifth, and when I add them up, I was right. It's 5 to the seventh. I have no idea what that equals, so you can type that into your calculator and see. It doesn't really matter, because the most important thing here is that we figured out what the rule is. So number 4, if I generalize, x to the fifth times x to the fifth, the important thing is the bases here are the same, and I see that in all of my other examples too. In number 1, my bases were 3. In number 2, my bases were 2. In number 3, my bases were 5. In number 4, my bases are x. So it looks like that follows the same format as the other problems. So if I add the exponents, x to the fifth times x to the fifth should be x to the 10th. I'm going to expand it out and make sure. There's x to the fifth times x to the fifth and I do in fact have x to the 10th. So when I generalize and go back to this box over here, my rule, x to the a times x to the b, since the bases are the same, would be x to the a plus b. So in words, when the bases are the same, we want to add the exponents. The other goal in this opener is to determine the rule for multiplying, raising an expression with a base and an exponent to an exponent. So I have a feeling this one might follow some similar rules, but I'm going to do the same thing. We'll go through the example first, then we'll generalize and see if we can find a pattern. So the first example is 3 to the second raised to the fourth power. So I know that raising something to the fourth power is the same as multiplying the base by itself 4 times. We just learned from the previous example that when we multiply things with the same base, we can add the exponents. We just generalized it up here. When the bases are the same, add the exponents. My bases are the same, so I can add the exponents. 2, 4, 6, 8. So that would be the same as 3 to the 8th. Now again, I always want to look for patterns and see if I can find a bigger rule. So when I see 3 to the 2nd and 3 to the 4th, and then I see that I ended up with 3 to the 8th, I have a feeling that I might be multiplying those exponents, but I want to do a couple more examples to make sure. So number 6 is 2 to the 4th, all raised to the 2nd power. So I'm going to take my base, 2 to the 4th, and I know that raising something to the 2nd power means multiplying it by itself. And again, what we just learned in the previous example, the bases are the same, so I can add the exponents, and I get 2 to the 8th. I look back again and see 2 to the 4th to the 2nd power, 2 to the 8th, and it looks like my hypothesis might have been right, but a lot of these numbers are kind of similar, so I want to do another one just to make sure. 5 to the 2nd raised to the 5th power is 5 to the 2nd multiplied by itself 5 times. And again, my bases are the same, so I can add the exponents. 2, 4, 6, 8, 10. 2 times 5 is 10. So it looks like that is the rule. When we're taking a power to a power, we can multiply the exponents. That'll make our lives a little bit easier than having to expand it every time, but if you can't remember the rule, you can always expand it out just to make sure. So x to the 5th power should be x to the 5 times 5, or x to the 25, but I can always expand it out just to make sure. And my bases are the same, so I add the exponents, 5, 10, 15, 20, 25. X to the 25th. So the rule I can generalize is when I'm taking a power to a power, I can multiply these exponents. So x to the a raised to the b power is the same as x to the ab. When taking a power to a power, multiply the exponents. So there's 2 new exponent rules for you. Good luck.